So this is exercise 13.5 on differentiation. Okay, so please remember that in these questions it doesn't matter having this blue box learned off by heart and reading what the question wants. So it says, find the coordinates of any determinant points of each of the following and determine whether they are local maximum or local minimum points. Well, we can see that this is an x to the power 4. If it's x to the power 4, this means it has 3 turning points. If it's x to the power 3, it means it has 2 turning points, and x to the power 2 will have 1 turning point, and finally x to the power 1 will only be 1 turning point. So it's whatever the highest power is. The highest power is 4, question 13 has 3 turning points. In question 12 the highest power is 3, which means 2 turning points. Okay, so what we're going to do next is we're going to look for turning points. Turning points happen when the first derivative equals 0. So we're going to rewrite this as y equals x to the power minus 4 using the rules of indices. It's going to be 1 over 4 x to the power minus 4. Or sorry, got that wrong, excuse me. So it's going to be a quarter x to the power 4, excuse me. So it's quarter x to the power 4 minus x cubed minus 5x squared plus 1. We're going to differentiate this. Now when we differentiate, the 4 goes to the front, multiplies by the quarter to give you 1. Take 1 away from the power and we get 1x3. 3 goes to the front, and then take 1 away from the power, 3x2. 2 goes to the front, multiplies by the minus 5 and becomes minus 10x. Then the 1 turns to a 0. The first derivative has to equal 0, which it now does. And now we got to solve, okay, so we actually have to find the coordinates. Coordinates means x values and y values. So what we're first going to do is find the x values, okay? So what we're going to do is we're going to take out x, because x is common to all 3. So we're going to get x brackets, x minus 3x minus 10, or say x squared minus 3x minus 10 equals 0. We're then going to do the reference number in this part here. Reference number is minus 10, which breaks up into minus 5 and plus 2. And what we're going to get is x bracket x minus 5 bracket x plus 2 all equals 0. Now when we solve this, what we're going to get is x equals the first value here, x equals 0, x minus 5 equals 0, or x plus 2 equals 0, x is going to equal minus 2, x is going to equal 5, and x is going to equal 0. Okay, upon completion of this, these are the points that exist on the graph. We want x equals 0, x equals 5, and x equals minus 2. So what I'm going to do is I'm going to use the table function in my calculator, and I'm going to make sure to include minus 2 up to 5. So what I'm going to do is going to look at this formula again, and I'm going to do a quarter x squared, or say 1 over 4x cubed, or x to the power 4, excuse me. To the power 4, then we're going to do minus x cubed, and then we're going to do minus 5x squared, and then plus 1, and then we're going to go from, let's say, minus 3 to plus, I don't know, 7. Okay, now let me tell you why I did it this way. So what this has done is it's calculated all the points for me that are on this graph. So what it does is it tells me what the 0 point is. So when it's 0, it's 1. So this is the point 0, 1. Okay. Next one I need is the number 5. So go back down, look for number 5. It's going to be 5 92 points minus 92.75. 5 minus 92.75. Okay. Which is basically minus 92 3/4, okay? And then the final one is going to be minus 2, and we find out what the minus 2 is. Minus 2 minus 7. Now, what I have to do is I have to determine whether each one of these is a maximum or a minimum. To do this, I get the second derivative and test if it's smaller than 0 or bigger than 0. So let's do that now. Second derivative. Now remember, the first derivative is this here. Okay, so what we can do here is we can just leave our first derivative and test out our 3 points. Okay, so the second derivative, is going to be d2y dx squared, and what we're going to get is 3 to the front, we're going to get 3x squared, 2 to the front, take away 1 from the power, it gives you minus 6x, bring 1 to the front, it's minus 10. Now, the first thing I'm going to do is going to test out all 3 x values. So when x equals 0, we're going to get 3 times 0 squared minus 6 times 0 minus 10, and that's going to give you minus 10, which is smaller than 0. Now if your second derivative is smaller than 0, it's a maximum. Okay, so this means that this one here is a max. Now that I've done that, what I'm going to do next is going to test out when x equals 5. So when x equals 5, it's going to be 3 times 5 squared minus 6 times 5 minus 10. And what's that going to be? It's going to be 75 minus 30. 75 minus 30 minus 10. And that's going to be 35. 35 is bigger than 0. This means that this one here is a minimum. And then finally, the last point to test is going to be minus 2. So we just do this down here. So x equals minus 2. And when we do this, we're going to get 3 times minus 2 squared minus 6 times minus 2 minus 10. Okay, so we put this into the calculator, and what we're going to get is 12 plus 12. So 12 plus 12 minus 10. And what we're finding now is that this one here is going to be 24 minus 10, which is 24 minus 10, which is going to be 24 minus 10, which is 14. 14 is bigger than 0, so this one here is also a minimum. Okay? So that's what we're expecting. Okay? Now finally, read the end of the question. Find the coordinates on your turn points each of the following, determine where they are local, max or minimum points. So we've done that one successfully. Now we're on question 15, which is the same type of question. So for question 15, we're going to realize it's a product rule, u and v. So we're going to, quotient rule. So we're going to get the y dx equals phi times du dx minus u times the v dx all over v squared. Okay, and we're probably going to do this once or twice. So u is ln x. Look this up in your notes. The u dx is going to be 1 over x, because that's what ln x is. And then we're going to get v is equal to x, and the v dx therefore equals 1. So when we differentiate for the first time, what we're going to get is phi times du dx, which is x times 1 over x, minus u times the v dx, which is going to be ln x times 1, all over phi squared, which is going to be x squared. And so what we're going to get here is we're going to get x divided by x is going to be 1 minus ln x all over x squared is the first derivative, and this has to equal 0, because for the first turning, for the turning points, dy dx equals 0. Let's solve this. X squared cross multiplies up, which means it disappears, and we're going to get 1 minus ln x equals 0. Therefore ln x equals 1. Okay, so what ln equals 1? So what we might need to do here is remember what ln means. ln means log to the base e x equals 1. This means x equals e to the power 1, x equals e. So now we know that x equals e is the turning point, okay? So we have to find out the y coordinate. So we know that e is the x coordinate, but what is the y coordinate? So we go back to the original function, which is ln x over x. So we put this into our calculator. So what it's going to be is ln e over e, because ln e over e, so ln e plus e to the power 1, so that's ln e. Okay, ln e is 1, so it's going to be ln e over e, which is going to be 1 over e. So this is a point e, 1 over e for the y-axis. We now have to figure out if this is a maximum or a minimum point. which means we are now going to have to differentiate the first derivative a second time. So here is the first derivative, and what we're going to have to do is differentiate it a second time. So this time what we're going to say is that u is 1 minus ln x, and this means that the u dx ends up to be 0 minus 1 over x, or simply minus 1 over x. Okay, now that that's done, what we're going to say is v is going to be equal x squared, so the v dx ends up to be 2x. Once again, we're going to put it into the quotient rule. So the quotient rule is going to be v times the u dx, which is going to be x squared times minus 1 over x, minus u times the v dx, which is going to be 1 minus ln x times 2x, all over v squared, which is going to be x squared to be squared. Now, have a quick look at this here. Multiply x squared by 1 minus 1 over x. The x cancels with 1 here, so we're going to get minus x. Then we're going to see the 2x. I'm going to multiply minus 1 by 2x at the start, and what we're going to get here is minus 2x. Okay, so technically in here is going to be minus 2x, and that's going to be multiplied by 1 minus ln x, so it's going to be minus 2x plus 2x ln x all over x to the power of 4, because 2 by 2 gives you 4. Then we're going to tidy this up, and what we're going to get is minus 3x plus 2x ln x. Okay, now we have to figure out if it's a maximum or a minimum. So what we need to do is substitute in the x value here and see if the second derivative is bigger or smaller than that. So it's going to be minus 3e plus 2e ln e all over e to the power 4. So what's going to happen here is we're going to get ln e is 1. 2e multiplied by 1 is 2e. So look, it might as well not be there. So we're going to get minus 3e plus 2e, which is minus 1e over e to the 4. And that's going to be cancelled off e to the power 1 here with e to the power 4. So it's going to be minus 1 over e to the power 3. Now, minus 1 over e to the power 3 is a smaller number than 0. You can check it out in your calculator if you really want. So we can say is minus 1 all over e cubed. Sorry, minus 1 all over e cubed, so shift e cubed, and we can see that this number is a minus number, which is less than 0, and this makes it a maximum turning point. It's a maximum turning point. Okay, so now that that one's done, we're on to part 19. Okay, so question 19. Question 19 is a chain rule. Okay, so it's a chain rule, and the chain rule is going to be the chain rule is located. So we'll do the chain rule here. Okay, so y equals 1 minus ln x squared. Now remember what the chain rule is. You differentiate once. Now you bring 2 to the front and treat it like a normal differentiation. It's going to be 2 times 1 minus ln x to the power 2 minus 1, which is the power 1. Power 1 doesn't need to be included. Now, you also got to remember to differentiate what's in the bracket. Differentiate 1, you get 0. Differentiate minus ln x, you get minus 1 over x. We're now going to multiply the 2 by the minus 1 over x, and we're going to get minus 2 over x bracket 1 minus ln x. Now, I suppose we might want to rewrite that. Multiplying by minus 2, we're going to get minus 2 plus 2 ln x when we multiply it in, all over x. Now, for turning points, the first derivative equals 0. So this has to equal 0. Cross multiply the x up, it disappears. So you're going to get minus 2 plus 2 ln x equals 0. Bring the 2 over the other side, you get 2 ln x equals 2. Divide both sides by 2, and we get ln x equals 1. And we all remember what ln means. It means log to the base e x equals 1. This means x, this number here, equals what's in the blue box to the power of what's in the green box. So it's going to be e to the power 1, x equals e. We now know what x is e. We now go back up to the original equation, which is this one here. And we're going to do is we're going to replace x with e. So we're going to get y therefore equals 1 minus ln e squared. Ln e happens to be 1. 1 minus 1 squared is 0 squared, which is going to be 0. So this means that this one here is going to be the point x is e, y is 0. Okay, now we have to figure out if it's a maximum or a minimum. Now, this here is the answer to the first derivative. We are now going to differentiate it again to get the second derivative to test if it's a maximum or a minimum. So, u equals minus 2 plus 2 ln x. Du dx therefore is going to equal, that's going to be a 0. 2 ln x is going to be 2 over x. And then, after that, what's going to happen is v equals x therefore du dx equals 1. Okay, so we're going to do the quotient rule on this now, and we're going to get phi times du dx, which is going to be x times so this one here is going to be x, which is phi times du dx, which is going to be 2 over x, and then minus u times the v dx, which is going to be minus 2 plus 2 ln x times the v dx, which is 1. Okay, so what we might do here is we might multiply, this one's a minus 1, multiply minus 1 by 1. It doesn't have to, this one at the end doesn't even have to be here, so we can just get rid of that. And then it's going to be all over x squared. Okay, so we're going to get is x times 2, 2x over x, which is the x's cancel, so we just get 2. Then we get minus 1 by minus 2 is another plus 2. Then we're going to get plus 2 ln x all over x squared. And that's going to be is 4 plus 2 ln x all over x squared. So x equals e, the x coordinate is e, so put in the e value, x equals e, and we're going to get is 4 plus 2 ln e all over e squared. Remember ln e is 1, 4 plus 2, 6, 6 over e squared. So 6 over e squared is bigger than 0, and this means that it's not a maximum but a minimum turning point. Minimum turning point, okay? So, moving on. This one here. The f of x equals e to the power e to the minus x. Find the first derivative. Okay, so the first derivative, we're going to use it using the product rule. U equals x, du dx equals 1, phi equals e to the minus x, du dx equals remember, this remains unchanged, so what you're doing is that the power goes in, okay, and what you need to do is you need to differentiate the power of e to the x. So you're going to differentiate minus x, and when you differentiate minus x you get minus 1, so minus 1 e to the x. Product rule is u to v dx plus phi du dx. So what we're going to get here is u is x, the v dx is going to be minus 1 e to the minus x, v is e to the minus x, and then the v dx is minus 1 e to the minus x. Put them in and we're going to get minus x e to the minus x, because I'm multiplying x by minus 1 and just leaving the e to the minus x where it is. Now this one here is going to be minus 1 because there's a 1 here by a 1 here, and then we're going to get e to the x by e to the x, which is e to the minus x squared, which is the same thing as e to the minus 2x. Okay, because that's the rule there. E to the minus 2x. Now, that is the first derivative. Question 20. Now, you could have left it, if you wanted, is you could oh, sorry, excuse me, I just made a mistake there. Du dx is 1. So, sorry, that last part there, unnecessary. Du dx is 1. So, excuse me, du dx is 1. So, it's going to be plus e to the minus x. Now, you can differentiate out e to the minus x, and we're going to get minus x plus 1. Or that is the same thing as e to the minus x 1 minus x. Now, next thing they want me to do is find the second derivative. So the second derivative is going to be another product rule, except this time u is e to the minus x. So once again, du dx is going to be minus 1 e to the minus x. V equals 1 minus x, and the v dx is going to be, that turns into 0, and this one turns into a minus 1. So this is going to be minus 1. And now what's going to happen is we're going to do the product rule. So u times the v dx, so e to the minus x times the v dx, which is minus 1. U times the v dx plus v times the u dx, which is 1 minus x into 1 minus 1 e to the minus x. And let's look what happens here. We're going to get minus 1 e to the minus x plus, now this is going to be 1 multiplied by minus 1 e to the minus x, which is minus 1 e to the minus x. And then we're going to have x times minus 1, which is this one here. And so that's going to be plus x e to the minus x. And then we're going to have minus 2 e to the minus x plus x e to the minus x. Or if we factorize that one out, we can get e to the minus x into minus 2 plus x, or that's the same thing as e to the minus x into x minus 2. Okay, what you want me to do next is find the coordinates of the turning point and determine if it's a maximum or minimum. Okay, so for the turning point, the first derivative equals 0, and the answer we have for the first derivative is e to the minus x into 1 minus x equals 0. So this means one of two things. There's two numbers here. That's the first number, that's the second number. So these two numbers equal 0. So we have a choice here. It's e to the minus x equals 0, or 1 minus x equals 0. Okay? Now, the problem here is we can have to ln both these, so we're going to get ln e to the minus x equals ln 0. We can bring the x to the front, it's going to be minus x ln e equals ln 0. ln e is 1, so minus x equals ln 0. What we're going to find out about ln 0 is that it's probably not defined. Mad error. So this answer here doesn't exist. Okay, that leaves us with this answer here, where we bring x over to one side and we get 1 equals x. Now we know that x equals 1. We now have to figure out what the y value is. Okay, so we know the x value, but we don't know the y value. We're going to go back up to the original equation and replace x with 1. So it's going to be 1 e to the minus 1, which is the same thing as 1 over e. So that's the y value. Now that that's established, what we're now going to have to do is figure out, this is the turning point, but we're going to figure out if it's a maximum or minimum. To do this, we're going to need the second derivative, and the second derivative is e to the minus x, x minus 2. And we're going to do is replace x with 1, so we're going to get e to the power minus 1, 1 minus 2. So we're going to get minus, that's a minus 1 there, so it's going to be minus 1 e to the minus 1, which is minus 1. Now e to the minus 1 is 1 over e, so it's going to be minus 1 over e. Now we know that this number here is going to be less than 0, which makes it a maximum turning point. Maximum turning point. Okay. Now Now that that's done, what we need to do next is find coordinates of the point of inflection. Now, the point of inflection is where the second derivative equals 0. So the second derivative equals 0 for the point of inflection. So therefore what we're going to get is, for the second derivative, the answer was e to the minus x into x minus 2. This in turn equals 0. So we're going to have two different parts here. We're going to have e to the minus x equals 0, or x minus 2 equals 0. Bring over the 2, x equals 2. This is like the last one. I'm going to ln both sides, but because it's an ln 0, it's going to be a maths error, so that means I don't have to do anything with this side. Only answer is x equals 2. But we now have to find out what the y coordinate is, because it says it wants the coordinates. The word coordinates means it wants both the x and the y value. So we need to go to the original function and replace x with 2. And we replace x with 2, we're going to get 2 e to the minus 2, which is going to be 2 over e squared. Okay, so that's where we're going to get our 2 over e squared from. Okay, so the curve y equals px squared plus qx plus r has a maximum turning point at 2,18, and another piece of information is 0, 10 is a point on the curve. Find the values of p, q and r. Well, what we can say is that if the y value is 18, the x value has to be 2. So we can say 18 equals p times 2 squared plus q times 2 plus r. So we can say is 18 equals 4p plus 2q plus r. Okay, so that can be equation 1, which is used only using the point. Next part is 0, 10. So we replace y with 10 and x with 0. So it's going to be p times 0 squared plus q times 0 plus r. And then we're going to find out that r equals 10. When we find out that r equals 10, we can replace this r here with 10, bring that 10 to the other side, and we're going to get 4p plus 2q equals 18 minus 10, which is 8. So there's our 1/2 of a simultaneous equation now. Now finally, it says maximum turning point. Maximum turning point means that the first derivative equals 0 when x equals 2. Okay, so what we're going to get here is we're going to differentiate the function to find out what dy dx is. Okay, so the y dx ends up to be, bring the 2 to the front, so it's going to be 2px. Differentiate qx, it's basically same thing, just the same thing as differentiating 2x, you get 2, differentiate 10x, you get 10, differentiate qx, you must get q. If you differentiate any number that hasn't got x beside it, it disappears. So it's going to be 2px plus q, and this equals 0 when x equals 2. So we've got to replace it in x equals 2. So it's going to be 4p plus q equals 0. And then we have the other half of the equation here, which is going to be 4p plus 2q equals 8. I'm going to multiply this one here by minus 1 to get minus 4p minus q equals 0. And we're going to find out is that q equals 8. Okay, now that we know that q equals 8, we're then going to put this in here. We're going to get 4p plus 8 equals 0. 4p equals minus 8. P therefore is minus 2. So we're going to get P is minus 2, Q is 8, and we already know that R equals 10. Okay, moving on. Question 23. The curve y equals e to the x multiplied by px squared plus q has a local minimum point at 1 minus 4e. Find the value of p and the value of q. Well, what we know first and foremost is this is a point on the curve. So when y gets replaced with minus 4e, this happens when x equals 1. So e to the 1, p times 1 squared plus q is going to be minus 4e, it's going to be that p by 1 squared is p, so it's going to be p plus q, so it's going to be ep plus eq. But look, we could have just struck off the e's on both sides because both sides are being multiplied by e, so we can just do it here. And what we're going to get is p plus q equals minus 4. Now that is 1/2 of a simultaneous equation. We're now going to try looking for the other half of that simultaneous equation using the information given. It says local minimum point. A minimum point is a turning point, and for turning points, do y dx equals 0 at x equals 1, because the turning point is x equals 1. So what we're going to do is going to differentiate this. So we're going to use the product rule. U equals e to the x, du dx is also e to the x, phi equals px squared plus q, and then dv dx equals 2px, and that goes to 0. So what we're going to get here is dy dx equals phi times du dx, so it's going to be px squared plus q by du dx, which is e to the x, so phi times du dx plus u times dv dx, so that's going to be e to the x times 2px. Okay, now you got to remember that x equals 1, so we're going to replace all the x's with 1 right away. So that's going to be p times 1 squared, which is going to be p plus q e to the power 1, which is e, plus e to the power 1. Remember, this x here is also the number 1 multiplied by 2p. So we're going to get pe plus qe plus 2pe all equals 0. We can factorize out the e, and we can get e into p plus q plus 2p, which is the same thing as 3p plus q. We'll just change that there. And this all equals 0. Now, if we bring the e from multiplication to division, 0 divided by e is still 0. So we're going to get 3p plus q equals 0. Another way of looking at it is e is being multiplied by the number in the green box. The answer is 0, therefore the number in the green box must be 0. Now, we have this other equation here, p plus q equals minus 4. I'm going to multiply that equation by minus 1. And what we're going to find out is that 2p equals 4, therefore p must equal 2. If we know p is 2, 2 plus q equals minus 4, bring over the 2, q therefore is minus 4 minus 2, q equals minus 6. So we know it's 2 and minus 6, okay? Moving on. Number 24. Okay, so what's asking is, given that y equals e to 2x cos 2x, find the first derivative, find the second derivative. So that's u and that's phi. So we're going to find out using the product rule, is that u equals e to the 2x, therefore du dx ends up to be e to the 2x, because it goes straight down, but you got to differentiate the power. When you differentiate the power, differentiate 2x, you get 2. So it's going to be 2 e to the 2x. Finally, we have phi equals cos 2x. Now, what we remember from cos is that it turns into minus sine. So straight away, it's going to turn into minus sine 2x. But you also got to differentiate the angle. Differentiate 2x, once again, you get 2. Multiply by 2. So it's going to be minus 2 sine 2x. Going to put that into the product, into the product formula. Okay, so we're going to get u times dv dx plus phi times du dx. So it's going to be e to the 2x times dv dx, which is minus 2 sine 2x. So that's phi times du dx, or sorry, u times dv dx, excuse me, plus phi times du dx, which is going to be cos 2x times 2e to the 2x. Okay? Now, we're told it has a maximum value, okay? So we need to write down what its maximum value is. Oh, sorry. We need to find the first and second derivative. So we're still on the first derivative at the moment. So once we've done that, what we're going to get is e minus 2 by e to the x is minus 2 e to the 2x sine 2x plus 2 e to the 2x cos 2x. Now, I suppose we should treat each one of these as its own rule. Okay. Now, what we can do here is we've already differentiated this part. So technically speaking, it's two product rules again. This is U and this is V. So two different questions, if you will. A green question, which is a standard product rule, and a blue question, if it was to extend out here, which is also its own question. Now, the trick is that we already know what the answer is for this blue part. It's actually the first derivative. It's actually the answer that we already have, because we've already differentiated this part successfully. Okay, so what's going to happen when we look at this is we're just going to differentiate this part on its own first. Okay, so this part here on its own, we're going to say that u equals so we're going to say that u equals minus 2 e to the 2x. Therefore, du dx, once again, remember that that power goes straight into the answer. Differentiate the power. It's 2. 2 multiplied by minus 2 should get you minus 4. Remember that v is sine 2x. Differentiate that. Then we get the v dx ends up to be, that turns directly into cos 2x. Differentiate the angle, and it comes 2 cos 2x. Put that into your formula, and we get the y dx ends up to be u times the v dx, which is minus 2 e to the 2x, the v dx, which is 2 cos 2x. Okay, and then we're going to get v times the u dx, which is going to be sine 2x multiplied by minus 4 e to the 2x. So what we're going to get here is we're going to get minus 4 e to the 2x cos 2x. That's basically the 2 by the 2 gives you the 4. And then we're going to get minus 4 e to the 2x sine 2x. Okay, now that's one part of it. So right here, we've only differentiated this part here so far. So this part here is the part we've differentiated. But what we know about this one is it's going to be 2 times the derivative of this part here. And this part here is in fact the full answer from the first part, because we already differentiated e to 2x cos 2x. So we're just going to put that answer into the brackets here. Okay, so we're going to get 2 times this answer, alright, which is going to be minus 4 e to the 2x sine 2x plus 4 e to the 2x cos 2x. Okay, so now that we've got this here, what we're going to do is just copy and paste it, or cut and paste it. Excuse me. So there it goes there. And then we're going to put it up here. Now we're going to reduce it in size a little bit, make it fit in. And there it is there. Okay, so that joins in at the end. So now we have both of them together. And what's going to happen next is that we're going to see what cancels. So we're going to see that will cancel with that one there, and we're going to be left with minus 8 e to the 2x sine 2x, because both these are sine 2x's, and then there's minus 4e to 2x minus 4e to 2x. When you add them together, it goes to minus 8 e to 2x sine 2x. Okay. Verify that e to the 2x cos 2x has a maximum value at x equals pi over 8, and write down this maximum value. Okay, so I have to verify it. So the first derivative, which is in green, first derivative has to equal 0. So we have minus 4 e to the 2x sine 2x plus 4 e to the 2x cos 2x, all has to equal 0. Now, factorize out 4 e to the 2x, and what we're left with is minus 4 sine 2x plus, oh sorry, not minus 4, the 4 is gone. So this is going to be minus sine 2x and cos 2x, and this equals 0. Now there's two distinct numbers here. There's the number in the green box, and if we try and figure out what that is, 4 e to 2x equals 0, we're going to get e to 2x equals 0. We're going to have to ln both sides, and like last time, when you have an ln 0, you're not going to solve it, so that's a loose end. Then we're going to have minus sine 2x plus cos 2x equals 0. Then we're going to bring over cos 2x equals sine 2x, and then we're going to divide across here, so we're going to get 1 equals sine 2x all over cos 2x, 1 equals tan 2x, and then basically what's going to happen here is we've got to figure out what angle is worth 1. We know that tan pi over 4 equals 1, so we know that pi over 4 should be the angle 2x, or basically 2x equals tan inverse 1, and then 2x equals pi over 4. Oh sorry, that's pi over 4, not pi over 8. And then once we divide by 2, we're going to get x equals pi over 8. So I've just after verifying that it has a maximum value at pi over 8, and write down this maximum value. So I have to write down the maximum value as well. So to write down the maximum value, it basically wants the y value. You say it's basically like the coordinate. Okay, the x value is the value at which the maximum occurs. The y value is actually the maximum value. So we're going to replace y with pi over 8, and what we're going to get is this. We're going to get e to the 2x, which is going to be 2 times pi over 8, and then we're going to get cos 2 times pi over 8. So we're going to get is this is going to be e to the pi over 4, and that's going to be cos pi over 4. Now cos pi over 4 is 1 over root 2, so it's going to be 1 over root 2 multiplied by e to the pi over 4, so it's going to be e to the pi over 4 all over root 2. That is the maximum value. Now I have to verify that it's a maximum as well, even though it only has one turning point. So this means that the second derivative must equal 0, or sorry, must be less than 0. So here's the second derivative here. So if it is a maximum, for maximum, second derivative is less than 0. The second derivative is minus e to the 2x sine 2x, and we have to verify that that's less than 0. We know that so we know that x equals pi over 8. So we're going to get is minus 8, and remember, if x is pi over 8, 2x is pi over 4, which you multiply by 2. So e to the power pi over 4 sine pi over 4 less than 0. Sine pi over 4 is 1 over root 2. So what we're going to get is minus 8 over root 2 e to the pi over 4 less than 0. This number here is less than 0. You can put it all into the calculator in one go if you want, and you can just obviously change it to decimals if you want. So minus 8e to the pi over 4. Divide that answer by root 2. And you can say that's minus 12.41. So minus 12.41 is less than 0, hence it's a maximum turning point. Okay. Now, number 26. Let f of x be e to the 2x minus e to the x, where a is a constant, a is bigger than 0. Show that f of x has a local minimum, and find the coordinates in terms of a. Okay, so what we're going to do is we're going to find the first and second derivative straight from the get-go. So this one here is going to be 2e to the 2x, like it was earlier. This one here is this a is a constant, so it's the same thing as minus 5e to the x. And what we know is that it's going to be e to the x when differentiated stays the same, so it's going to end up to be minus 5e to the x, which means that this is going to stay as minus a e to the x. Okay? Because e to the x is its own derivative. Then go again for the second derivative. And when you do the second derivative, what we're going to get is this once again differentiates into itself. With one exception though, because you got to differentiate the power, which makes it another 2. 2 by 2 gives us 4. And once again, this one here, the a goes directly down, and this differentiates back into itself. And now we know what the second derivative is. Now, what we're asked to do is find the local minimum and find the coordinates. Okay, so what we need to do here is we're going to find out we're going to solve this equal to 0. So that's minus a e to the x. And when this equals 0, we got to figure out what's happening here. Now, something to remember, this is e to the 2x is 2 e to the x by e to the x. And this is minus a e to the x equals 0. Take out e to the x, and we can get e to the x into 2 e to the x minus a equals 0. Now remember what happened last time when we tried solving e to the x equals 0. So this means that there's two numbers here. This is the first number, and this one here is the second number, and both of them equal 0. So what we're going to get is e to the x equals 0. You'd end up ln on both sides. Ln e to the x equals ln 0. Because it's ln 0, it's a dead end. So you would have got x ln e, which is x equals ln 0. Ln 0 isn't defined in your calculator. Now we're going to get 2 e to the x minus a equals 0. Bring over the a. 2 e to the x equals a. E to the x equals a over 2. Ln both sides are going to get ln e to the x equals ln a over 2. Bring the x to the front. X ln e equals ln a over 2. Ln e is 1, so x equals ln a over 2. Okay, so x equals ln a over 2. Now, it wants the coordinates in terms of a. So I've already used the first derivative, which means I don't need it anymore. And what's going to happen next, and I already got x equals ln a over 2. So what I've got to do is I've got to replace y with this. I've got to find the y value. So y equals e to the power of 2 times ln a over 2. And then minus a times e to the power of ln a over 2. Now, what I can do is I can write this as y equals e to the power of 2 ln a over 2. Now you got to remember, when the 2 is in the power position, that can also work as this. You move the 2 over into the power position, so we're going to get ln a over 2 squared. because 2 ln a equals ln a squared, or 2 ln a over 2 equals 2 bracket ln a over 2 squared. That's a log rule. Okay, so any log, so for example that's equal to log x to the power 3. That's one of the log rules, okay, you would have learned in the log chapter. Now that I've done that, and then I have minus a e ln a over 2. Now the interesting thing to remember about exponential and logs is that they're inverses of each other. So for example, e ln 3, if you were to put that in your calculator, e ln 3 is 3. E ln 100 is 100. So the e and the ln basically cancel each other out. E ln and anything inside this box results in the answer inside this box. So what's going to happen here is the e and the ln cancel, and I'm going to get a over 2 squared. And this one here is going to cancel, so I'm going to get minus a into a over 2. So I'm going to get is a squared over 4 minus a squared over 2, which is going to be minus a squared over 4. It's basically quarter minus a half, which is minus a quarter. Okay, so that's the turning point there, is therefore going to be ln a over 2 and minus a squared over 4. Now, prove that it has a local maximum. So I had to prove that this here is a local maximum. There's the second derivative. We know that x equals ln a over 2. So what we can do here is we're going to get 4 e to the power of 2 ln a over 2 minus a e ln a over 2. So what's going to happen here is the same thing as last time. We're going to get equals 4 e to the power of ln a over 2 squared minus a e ln a over 2. Now remember, e and ln are inverses of each other, so we're going to get 4 times a over 2 squared minus a times a over 2. And what we're going to get here is going to be 4 multiplied by a squared over 4 when we square a over 2 by a over 2. Now we're going to get minus a squared over 2. Multiply out and we're going to get a squared minus a squared over 2. And this is going to be, it's basically like 1 minus a half, which is going to be a half a squared over 2. A squared over 2 is always bigger than 0, and this means it therefore is a minimum. Second derivative is bigger than 0, it's a minimum. Okay. Now, number 27.